My name is Drew Tonneson. I work for Dell on the PowerFlex and the PowerMax, and I produce demos as part of my blog, drewtonneson.wordpress.com. For this particular demo, what I'm going to show you is how to do an offline migration from SCSI protocol of a data store, presenting a data store via fiber channel or iSCSI, and then converting that over to NVMe over fabrics, in this case TCP, but if you're on the PowerMax, you would also have the option of doing it via fiber channel, depending on the platform that you're on. And so what I'm going to do is go through the process that we developed with VMware. This process is available as a KB, which I've pointed out in my blog, but I kind of wanted to walk through, how you'd go about doing it, just real life, and kind of just as if I were doing a presentation. So I'm not editing this video to make it cleaner. I'm just going to walk through it. If I make mistakes, I make mistakes. I just want you to see how this is done. So right now, before the KB came out, if you wanted to get over to, and we're just going to say TCP because that's what I'm working with. If you wanted to get over to NVMe over Fabrics using TCP, you could only use storage vMotion. So traditional migration, I'm going to go into my virtual machine that is living in VMFS on, let's say, a fiber channel presented device. For PowerFlex, an IP-based SDC presented device, and I'm just going to move it over to the TCP data store. Perfectly fine, right? And I've done blog posts on that, and you can just read how that one goes. But I mean, it's straightforward. A lot of customers, I would say majority of our enterprise customers certainly, have a lot of virtual machines. And believe it or not, if you do the math, it can take weeks if they were to try to do a storage vMotion of all of them over to TCP if they wanted to convert. And part of the reason for that is, limitations on the VMware side. You can only do so many concurrent SVMotions per host. You can only do so many per data store, both source and target. There are limitations, and so it would take a while. Now, most customers don't require all of their environment, all of their virtual machines to be up 24/7. It's just not necessary. So for those larger customers, what they would do if they wanted to get over, let's say, to TCP, is they're going to come up with a list of virtual machines that must be maintained 24/7, and those could be designated to move with storage vMotion. And then all the other ones could be done offline, and that's what this is for. This process is how can I go about converting them offline, which has the great advantage of not moving the data, right? So the whole point of the offline migration is I'm going to convert it, right? I'm going to convert the data store. I'm not going to have to migrate the data. So I take a minimal amount of downtime to do some maintenance activities, which is what this video is going to show you. And after that, I'm up and running available. Now, the first thing we want to do is designate our data store that we're going to convert. So I have a data store you can see here called VMFS for TCP conversion, right? This data store is presented from my PowerFlex. You can see I have the VSI plugin here, which tells me it's living on the PowerFlex. Here's my volume name. If I want to hit the details and get some information about it, I can also do that. Then provision gives me some performance. Here's the size. Here's the storage pools. And then my host SDC mappings, right? So here's my mapping to this particular host, right? And I'm only using one host for this example just to keep it easy. But there's no problem with doing the migration, with multiple hosts. So you can see I have a separate cluster here, just this one host. And here's my conversion data store. Now, if I jump over to, I can jump over to my PowerFlex manager here and show you that the volume is here, right? Presented through, SDC, right? And what we're going to do is we're going to eventually map this through NVMe. You can see here's this protocol instead, right? So that'll be the whole process we're going to do. I'm not going into great detail about how to configure NVMeoF fabrics on the PowerFlex or the PowerMax, because this process applies to either. In fact, it applies to any of our arrays that are NVMe over fabrics capable. So you'll have to, the assumption is you've done that already, right? If you're at the point of conversion, you've already done this. So I'm not going to spend any time on that. So let's jump back to our environment here. Now VMware has come up with a number of checks that they want to have performed before you're actually going to convert a particular data store. A lot of these are just safety things. You shouldn't really expect to have any adverse output from these commands, telling you something's wrong. It's really just due diligence, and so VMware wanted to, make sure these are run just so everything's okay. So the first thing that we're going to do is we'll go back into our data store, and we just want to take note of the device backing here. So we're going to be using the device name and the partition here in some of the commands. And when it's presented via SDC, you get the extended universal identifier, this EUI, as opposed to like if I presented this via fiber channel iSCSI, I would have an NAA. But the EUI number here, I just want to kind of remember the N numbers here, which what matters. So this ends in 4. I don't have many devices presented, so I know I'm just going to look for 4, and that'll be the device that I have to query. And so speaking of querying, let's go into the host. So here's my ESXi host. So I've just created a couple of files here, just to make my life easy. So the first thing we want to do is that we want to check that VAI is supported on our device, which is basically the ATS command. ATS has been around a long time, and the chances of your device not being supported by ATS are extremely low. But we'll check it anyway. So we're just basically going to run this to tell us what our lock mode is. So let's do that. So here it tells us your locking mode is ATS. If it was set to SCSI, then that would be a problem. We couldn't actually convert that environment. It's got to have ATS to start with. The other thing we're looking for here is our type, right? So VMFS 6, we can't convert VMFS 5. So if you have VMFS 5 and you haven't gone to 6 yet, which has got to be a real small amount of customers, you have to get to 6 first. Now, since you can't convert in place from 5 to 6, there's no upgrade path. At that point, you may decide, well, there's no point in upgrading to 6 since I'm going to have to basically do a storage vMotion to get to 6. I might as well just do the storage vMotion to NVMe over fabrics. So VMFS 5 customers will kind of have to decide if they're looking to convert, whether they just want to do a storage vMotion straight over rather than converting in place and then doing it again. So with ATS checked, we then move back to our environment here in VMware. And the next thing we want to look at is the virtual machines that live on the data store. So these are, what we're going to move over. And I say move, we basically are going to unregister them and re-register them. So what we need to look for is, there are restrictions around conversions, and there's a number of them, but the high-level ones are, there is no support for the clustered VMDK, so keep that in mind. The other thing that can't be converted in the environment is any virtual machine that has a raw device mapping. So there are no raw device mappings with NVMe over fabrics. So VMware's been trying to get people away from it so that they just won't use them anymore. A lot of customers still use them. If you do, you're going to have to convert them first to regular VMDKs before you're able to move them over to NVMe over fabrics. Or if you decide that you're going to have a mixed environment, you're just going to leave those virtual machines running on SCSI, and then convert the other virtual machines. But these particular virtual machines, we'll, pop through them and just take a quick look. Right, so this one has a couple of hard disks associated with it, but these aren't RDMs, they're just regular disks, right? A couple of thin provision disks. And then my other two virtual machines here are Oracle Rack VM1 and VM2. So we take a look at these. So here I have a number of disks too. Now with this one, because I'm using Oracle Rack, I don't have RDMs, but I am sharing the disk, right? So I'm using the multi-writer feature for Oracle Rack. Now that is supported for conversion. There's no issue with that from technology standpoint. There is an issue when we get over to TCP when it comes to registering the virtual machines, because disk files, right, are going to be designated here like this, but in reality, when you look inside the VMX file, VMware is using the UUID, right? And as you'll see, we're actually going to be changing the UUID on the disk. And because of that, when we go and register, this original virtual machine that owns the disks, Oracle Rack VM1, will be okay. It'll know where to look for the disks because it was the initial owner of the disks. Rack VM2, which is sharing the disks, pointing to Rack VM1, it's going to tell us it doesn't know where the disks are. So for any shared disks using multi-writer, we're actually going to have to repoint the disks again, and I'll show you how that's going to work. But ultimately here, we're just looking to make sure we have no RDMs, and we don't. As I said, this one's going to look exactly like the other one because it's got the shared disks. So here's its two 50 gig shared disks. Okay, so no problem there. We're good with that. So once we validate that the VMs are okay, we can move to the next step. And so the next step is going to be, we're just going to power down the virtual machines. So the virtual machines, as I said, they can't be up. This is an offline migration, right? So we're going to do a guest OS. We're going to do a guest OS shutdown, and let's shut down those virtual machines. Shouldn't take too long. They're not very big. Okay, so our VMs have powered down. So now what we want to do is remove them, right? So we don't want to remove them as in delete them. We just want to unregister them, right? So remove from inventory. So all this is going to do, of course, is just pull it out of the known virtual machines that vCenter has, and our data store will now be empty. Obviously, if we went in and looked in ESXi, I guess I might as well, look in our volumes and our VMFS, we'll see, our virtual machines are still there. They haven't moved. They still exist. Okay, so after unregistering them, we want to unmount the data store. Okay, so I'm doing this on a single host, which obviously makes life pretty easy. If you have multiple hosts and you have other virtual machines running on those hosts somewhere, obviously you've got to unregister. Anything that is on the data store or VMware is not going to allow you to unmount it. So this one's easy enough since I only have it on the single host. And unmount is successful, so we're good there. Now we go into where VMware wants to do some consistency testing. Okay, so we'll go back to one of these scripts and we're going to do a VMFS check. So VMware has this utility called VOMA, and this VOMA utility will go through and check the integrity of the device. Now, as we're looking through here, the device, what we have to provide VOMA is the partition, the device, and then the partition number. assuming you're not doing multiple extents, which you shouldn't. Your partition number here is going to be 1. And if you remember, I was looking for those 004 number. So that's the disk I have. So what this is going to do is it's going to go through, it's going to put a SCSI2 reservation on the disk so that it can go through and do the integrity checking. By the way, one of the things that NVMe over Fabrics doesn't support is SCSI2 reservations, and you'll see next time we run this command, we can't use SCSI2, so you'll see how we do that. So we'll just paste this thing in. It's going to go through and do a quick check of everything. Yes, I found a file system, blah, blah, blah. Let me run through these phases. I found no errors. I'm good. There is a process to fix it if it found errors, and that's in the documentation. It'll go through and fix it, kind of like an FS check, go through check, and then fix errors. I've never had a device that had errors, and as I said, VMware does this mostly for just sanity checking. So running through that and completing correctly, what we want to do is come back to our environment here and go in to actually look at the disks from the host level, and we're going to want to detach it. This is, by the way, if you run a PowerMax 2, in that my best practices book, I go through and I explain how if you were going to run a refresh of a data store, which is kind of like this, you would always want to run a detach. So you want to do the detach, not simply unmap it or unmask it. You want to run the detach first. It just makes it clean. So we'll find our 320 device. There's our data store. We're going to run through here and we're going to detach it. Do you want to detach it? I want to detach it. So that'll go through into its gray state. There we go. And we've entered into, now we're detached. You can see over here, this column here, detached. All right, once it's detached, we're going to go into our PowerFlex environment. Here we go. Okay, scroll down and find our volume here, 320. We'll click on that and we'll come up to mapping and we'll select unmap. I only have it mapped to the single ESXi host. Click that, click unmap, successfully unmapped. Now that we've unmapped it from traditional SCSI, let's go back and map it properly to NVMe. So up top here, we default to the SDC. SDC is what's going to be the SCSI presentation. So we want to change that to NVMe so that it will provide us all the NVMe hosts that are available. And here's our one host. So we'll click that and we'll click map. And we've mapped successfully to our NVMe host. You can see here the host protocol has changed from SDC to NVMe. Let's go back into our environment here, and now let's see if the device is available. So we'll go to our storage adapters here. This is where we'll have configured the NVMe TCP storage adapter. So we'll click on that, and then we'll click on devices, and there you can see our devices here, 320 gig, the one we just presented. I've never seen a situation where I had to rescan. The TCP adapter should immediately pick up the device. That's just how NVMe over Fabrics works. In the KB, VMware insisted I have a rescan in there, so I'm like, okay. So if you want to run a rescan, you can. You don't need to. The device is here, so we're good. With the device presented, or we'll say it's now attached again. We want to run another check, another VOMA check for the device. So we're going to run, in this case, an NVMe check. Now, the only difference here is going to be this switch here, this -N. And what this -N tells VOMA to do is to ignore the fact that it can't do a SCSI2 reservation because there are no SCSI2 reservations on an NVMe over Fabrics presented device because there's no SCSI, right? So we have to tell it to use that switch, which will ignore and not try to do the SCSI2 reservation. However, we will get a warning about it to let us know, oh, first thing we want to do is get the new label, right? So here, we come back out here to our EUI devices, and we want to get the device for the NVMe over Fabrics. Now you can see the format difference here to the old ones, right? The beginning numbers here versus the other ones here. So you can see the difference in the types of numbering for the devices, right? So let's go into our environment here and just check the last digits here. So now in this case, unlike our SCSI presented device, we can't simply look at the last numbers because it doesn't work that way. We got to look in the middle. So in the middle, we see a 464B, and since that doesn't exist anywhere else, we will just look for the 464B. So I can come in here and I'm going to look my 464B, which is here, 464B. So we grab our name there. We'll bring back our command and then we'll paste the new device number and then a colon. So as I said, it's going to ask me if I'm okay with running this command because I have to validate no one's trying to access it. Because I haven't gone in and created the data store again, you can see here that I'm not really in any, there's no harm because nobody else is going to be using it. So I'm sorry, select a number here, yes. It's going to run through the same things, right? It's going to go through and it should come back and say, yeah, I haven't found any problems because I didn't find any problems the first time. So with the integrity checked, what we want to do is we want to basically mount the data store again because it does have a partition on it with the data store. The key here now, though, is that the number, as you've just seen and I've proven, it is different, right? So I have a different UUID, I have a different, I should say I'm going to have a different UUID. I have a different EUI number, right, that we have, not that 004, now I have this number. And so because I have this number, what's going to happen is VMware is going to look at this number and is going to compare it to the signature on the data store, which is using this UUID, and it's going to say, I don't match anymore because your device ID has changed. Your UUID still says this. You need a new UUID, and a new UUID means you need a new signature, right? So as far as VMware is concerned, this basically becomes like a snapshot. So if you're taking a data store and created a snapshot of the device on the PowerFlex or the PowerMax and represented it, VMware would recognize it as a snapshot because now the device ID is different than what's in the metadata for the signature. Same thing here. In the KB article, we do it based at the CLI. Let's go back in and do it through the GUI instead. So we'll come up to storage, new data store, VMFS. So here, what I want to see is, let's drop some of these columns so we can actually see. We'll get rid of our cluster VMDK, which has no support anyway. We'll get rid of all these lovely things, hardware acceleration. Yeah, let's do that. So now here, you can see our snapshot volume is the data store name, right? So head just means that it's the first partition, in this case, the only partition, right? So we're going to select that disk. The name up here doesn't matter because it just ignores this piece up here whenever you're doing a snapshot. Now it says, how do you want to deal with this? Because we have an unresolved signature, meaning what I just explained, that metadata doesn't match. Your device ID has changed, your signature is invalid. We need to assign a new signature, and we have to assign a new signature. So we'll click through that, and it's going to then assign it, and it's going to mount our data store for us. Now, despite what the wizard showed that it's going to name this data store, it's not going to name the data store. It's going to do what it always does, which is name the data store snap dash something something, and then the name of the data store, right? That's how VMware deals with the snapshots, and for good reason, in case you actually still are presenting the original device, it doesn't want to have a conflict. Okay, so what we're going to do is, and this is optional, is we're going to rename it because I don't want that snap thing. I want to go back to the original name, and part of the reason too is I want to use the original name so that when I register my VM, it's not going to have any issue, right? So after I've registered it, I'm going to go into it and go into my files, and now I'm going to register the virtual machine. So let's start with the regular virtual machine here, just that standard one that had a couple of devices associated with it. So we'll go find the VMX file, we'll click on it, register VM, we'll keep that, move through. We want to put it, and we have to put it on the same host, obviously, where it's presented, and we'll finish this. Okay. After registering this, I want to start it up because I want to be able to show you what might happen, which I assume is going to happen here. So I'm going to click on this and tell it to power on. And what I'm looking for here is whether we're going to get a bit of a hang here as it waits. So I click on my virtual machine here, and what I get is this little message here, right, saying that it looks like you've either moved or copied this virtual machine. You've got to tell me how to deal with it before I bring it up. All right, so we click answer question, and we want to say we copied it. We don't want to move it, we want to copy it. So we answer that. As soon as we tell it we copied it, it will then finish the power on, and we're good. So we got one down here. Let's go look at the other two virtual machines. So here we have our rack. We'll do our rack one first. Here's our VMX file. Register our machine. Again, picking our host. Okay, we'll go in and we'll just look at the settings here. Yeah, all looks good. So we'll power it on, and then of course, probably going to get that same message that we'll have to answer. Answer our question, copied it. Good, start up. Now finally, let's do the last virtual machine. So come in here, find our VMX, register virtual machine. Now, as you can see, the registration went through fine. Okay, so here's my virtual machine. But now I got these messages here. Some of the disks of the virtual machine failed to load. Okay, what does that mean? Let me go check that out. Oh, so my disk 3 and 4 are both 0. Now remember, way back where I said it uses that ID to figure out where the disk is, and all of a sudden it's lost reference to it because we changed the signature, right? When the virtual machine owns that disk, one, doesn't have any issue, can resolve locally. But this one, in the VMX file, it pointed over to the UID directly, and now it says, well, I don't know what that disk is, and it can't resolve it. So what we want to do is we want to go in and just take a look at the disks, make sure we know the names, 1113, and we've got to remove them. So we will remove those disks, right? I'm going to remove them completely, say OK, and then I'm going to come back in and I'm going to add them back. So we'll go into our existing hard disk and we'll just run through here finding them. 11 and 13. Whoops, wrong folder. 13. Okay, now it doesn't know, VMware meaning, it doesn't know that these are shared disks that had multi-writer set, so I'm going to have to go in and set multi-writer again, right? It's not automatically going to pick that up. Set multi-writer, okay. And then once it reconfigures again, I can power this one on. This one will still, I'm still going to get the complaint that it's been copied or moved, but it shouldn't have any issue powering on now that I told it where the disks are. So we'll answer the question. I copied it, power on. And if we go back and look at our other VMs, you can see here in the little window, that one's up, and our rack 1's up, and then our rack 2 is coming up. And that concludes the conversion. So for each of your data stores that you want to convert from SCSI over to NVMe or Fabrics, this is how you're going to do it. Since it is done data store by data store, this can be planned. You can take your time doing it. We will, I think, Dell, meaning we will eventually probably have some sort of scripting capability around some of this. It was important, though, that we get the process available for customers who needed it. And as you can see, it's not, other than the few steps you're doing for checking integrity, it's not very difficult. And in fact, even where we develop a script, some customers may not want to use that and may want to do it manually like this to make sure everything gets done properly. But as you can see, I didn't have to move any data. The process itself is going to be quicker than doing storage vMotions. So the more that in a conversion project you're able to relegate virtual machines that can experience some downtime, and it doesn't have to be long, it's more beneficial than trying to do storage vMotions for all these virtual machines over to NVMe over Fabrics. Thanks.